we're live. Here we go. We're going to be talking about number 5 off your homework first. I want you to understand something here. Does everybody see that these are smooshed together? Smooshed together. So what we want to do, we can solve this without breaking it apart. We're allowed to solve this without breaking it apart. I want us only to look at the middle. Only look at the middle. We got a 6x plus 4. Now, if that's all I gave you, how would you start solving this to isolate the k? You want to get the 6 all out of there, and then we also want to get the 4 out of there. Which one would you get rid of first?
4.
The 4. How do you undo positive 4? Here's the beauty of this. Usually we say what we do to one side, we do to the other. Now we have to say what you do to one side, you do to all sides. Because there's technically 3 sides here. Does that make sense? There's 3 parts to this. Now they're giving us, it's called compound inequalities, because there's 2 of them being involved here. Doesn't change what you do, just multiplies the number of sides you do it to. We're left with 24 greater than 6k greater than 12. Okay? You. Thought about saying it. What would I do?
Divide by 6.
And again, what you do to one, you do to all. We're doing okay? We end up with 4 greater than k greater than 2. Bear with me here. Now, this represents an and inequality. And inequality. When it's smooshed together, it's and. So this is your final inequality answer. But I want you to understand what's really going on. I need my k values to be less than 4. Does everybody see that's what this side says? We read from the perspective of the variable. And, meaning binding, both conditions have to be satisfied. K has to be greater than 2. So that's really what's going on with our inequality answers. So when I go to graph, I'm going to do a scrap graph first. Scrap graph just means it's not our answer, it's just to help me see what we're going to be doing. If I were to graph k less than 4, would that be an open or closed circle? Open or closed?
Open.
Excellent. Going which way, left or right? If we're less than, we're left than. Less than, left than. You're welcome. And then 2, open or closed? Open, going which way? All you gotta do is think with an Australian accent. Right, then you go to the right side. Hey, mates? No? Nothing? Whatever. So, this is important. Look for what I call the overlap. The overlap. Remember our situation where we said you have to do pencil and paper? You only were gonna pass if you brought both? Where's the only area where both are being hit?
And between the 2 and the 4?
In the middle. This is the money section. So again, this is my scrap graph. I can't have arrows on the graph because that would kind of insinuate that everything works. No, 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 no. Only thing that works is between. So there's my inequality answer. My graph answer would be from 2 to 4 with the shading in between. Those are the only numbers that satisfy both of my conditions. Interval notation now. Least to greatest. Least to greatest. It's easiest to see it from your graph. What's the smallest possible answer here? 2. What's the largest one? Now, parenthesis or bracket?
Parentheses.
Why?
They're not included.
Bingo, bango. Open circles, they're not equal to, means it is not a part of the solution, it's just where we stop, which is why we have the parentheses. And inequalities. Has to satisfy both conditions. All good? Ready for number 2? Here we go. Notice a big difference. Mainly a big word, a little word. But, or. So this is the nice part. We're going to solve each of these separate. We're going to solve each of these separate. So I need your help with the first one. How would you start solving? I would also. You get 6y less than negative 24. Come on. Divide by 6. I like it. we get y less than -4. I mean, this is not the tough part of the lesson, right? We can all solve two-step inequalities. It's very nice. Everybody's avoiding eye contact. I love it. You, can you help me solve the second one?
Subtract 2.
All right. Everybody with me, right? You, help me with the next step.
Divide by 4. -4.
Very good. Okay, that's really, really important. Does everybody hear what she said? Divide by -4. Did you switch it? You had to. She took action with the negative, and we're left with y greater than 7. This word's important, though. This or that. This or that. So this is our inequality answer. That's our inequality answer. When I go to graph, I have a -4 and I have a 7. Open and close at -4. Anyone? Open. Going which way? Left. We are less than, we are left than. And you. Eyeballs. You. Open or close at 7. Going which way, right or left? Good man. Looks a little different, but that's allowed, right? Because we don't have to have both. Left or right, doesn't matter. That is your final inequality answer and graph answer. Let's be careful now. Interval notation. Last thing and then we're done. Last thing. Question of the day. Looking at the graph, what's your smallest possible answer? Who said that back here? Say again? Negative infinity. Because look, this doesn't stop. I know it's tempting to say -4 because it's like, well, that's one I see. Agreed. Doesn't stop going there though. So the smallest possible answer is negative infinity. And then it comes all the way up to what number? Stops at -4 for a little bit. Does it get brackets or parentheses? Parentheses, because infinity you can't stop. And -4 not included. Oh, what's this word? Or, where's it pick back up?
Okay, so it'd be positive infinity.
Okay, but where does it start?
7, my apologies.
Yep, and goes off to
Positive infinity.
and beyond. And what do they get?
Both parentheses.
Good man. Now keep in mind, if we had a closed circle, that would have had brackets, right? If it's included, it's brackets. Quick rundown on compound inequalities, both and or.